Hello and welcome to another episode of Angles and Acid, where we learn things maths and science. In today's video, we're learning about prime decomposition. So obviously we just did a video about primes and all that. So basically things can only be divided by itself and the number one. So they don't really have any useful divisors or factors that you could think of. So what's this whole decomposition thing? Well, basically try to take a really big number, break it all out into small things that multiply all together. But we want to make sure that all of those factors that we pull out, they're all the primes. So how do we do that? We can go back to our factor trees and we just basically pick off the ends of the branches. So if I've got the number 64 and I'm looking for a prime decomposition of 64, well, let me just change my brush color. Well, I can look at what factors does it have. Well, I like the fact that 64 is even, so I always like to work there. It's easy. So I can pull out a factor of 2. 2 times what gives me 64? Well, 32. So 2 and 32 multiply together gives me 64. 2 is prime, so I can circle that and keep that for later. 32, let's see if we can break that further into more factors. So again, it's even, so I like to start there. So let's take out another 2. So 2 times what gives me 32? I think 15, 16? I think 16, yep, 16 would work. And 2 is also prime. Remember, prime can only be divided by itself or the number 1, so 2 fits that description. 16, also even, so let's break out another 2. And 2 times 8, I believe. 8, and then let's keep going. Oops, sorry, I shouldn't circle 8, it's not a prime. 8, that can be broken up into 2 and 4. And then 4 obviously can be broken into 2 and 2. So a prime decomposition is you do all this factor tree and you find basically the terminations. So that means the end of a single branch, okay? So every termination of those branches of the factor tree, you will basically end at a prime. Basically collect them all and then write them out as a multiplication. So here I've got 2 times 2 times 2 times 2 times 2 times 2. And that equals 64. That will be the prime decomposition of 64. I probably should have picked a better number that's more interesting. It's just 2 multiplied by itself many times. But remember, just in the previous video, we can shorten that. So let's actually do the last step, which is to actually write the prime decomposition. So there's 2 times 2. Let's see, how many times is that? 1, 2, 3, 4, 5, 6. 6 times it. Okay, so it's 2, 3, 4, 5, and 6. Whoops, I wrote the number 5 by accident. And then we know that we can actually shorten that using index form or power form. So 1, 2, 3, 4, 5, 6, because I've forgotten already. 2 to the power of 6 is equivalent to 64. So that's basically what prime decomposition is. Find the factors, use a factor tree. It turns out that if you're looking for primes, it doesn't matter which 2 factors you start with. So I started with 2 and the corresponding other factor that goes with it. But it turns out that if you do a prime decomposition, it doesn't matter which ones you start with. You'll always end up with the same set of primes at the very ends of all your branches. However, if you're trying to find all the factors, just factors in general, then you might want to do a whole set using even and another set trying to do a 3 and so on. But that's the end of the video. So I'll catch you in the next video and I will leave you a link right here. See ya.